So today we're going to start our 2D split screen multiplayer car racing game. We got some assets I'm going to grab from Kenny's. I'll put a link down below. And there's also a car controller that I really like. It's written in GD script, and since this series is focused on using C#, I'm going to go ahead and just convert that one to C#. I'll leave a link down below where you can grab the original GD script version if that's what you want. He also has a video on exactly why he's doing certain things. So I'll leave the more in-depth description to him. Again, I'll link to the website so you can go watch that as well. But with that said, let's go ahead. We'll jump in. We'll go start our project and let's go grab some assets and make some C# scripts. Okay, so I've gone ahead and opened up Godot. I'm going to make a new project. I'm going to, doesn't really matter where I save it. For now, I'm just going to throw it onto my desktop. I'll create a new folder. I'm going to call this one, 2D Cars Split Screen. I'm going to save that off. We'll create our folder. Sorry, we just did the create folder. We'll select the current folder. Great. Now let's just go ahead and create and edit. Okay, so I'm going to set up a little bit of a folder structure. I like the split screen folders here, so I'm going to click this button. And in my res, I'm just going to right click. I'll create a new folder, which I'm just going to call cars. Now let's go grab those assets. Again, I'll leave the link down below, but we're going to head over to kenny.nl and I'm going to grab his racing pack. So I'll just go ahead, we'll download it. I'm just going to throw it onto my desktop. Now, once that is done, I'll just extract it. And the folder that I extracted has everything I need in it and then some. I guess we can go through and clean some of this up. Make sure to read the license. I'm just going to keep the 3 folders. I'll stop it, grab it, and I'm going to drag it into the folder up here under res. Now it's going to import all the assets, so just hold on, let it import the stuff, and we'll continue from there. Now once it's imported, I'm going to full screen it. I'm actually going to make a new folder here. I'm going to call it assets. This will be where I keep all of my sprites and everything else. I'm going to drag Kenny into that. We should put him in a sprites folder. And since I'm organizing stuff, let's do that now. So again, we'll click in there, we'll right click, new folder. I think this is the only sprites we're ever going to have. And let's pluralize it. Then drag Kenny into there. Then we can set up our first scene for the car. Okay, I'm going to come back to the root folder. I'm going to right click, create a new folder called scenes. Now, I've seen a bit of a divide how people tend to break up their projects. Some people will have a separate scripts folder that they keep all of their scripts in. And then they'll have the scenes, which you keep all of your scenes in. And then I've seen some people combine them where they'll have their car sprites, their car sounds, like everything to do with the car will be inside that car folder along with the scripts. I kind of like that way because if I ever want to go and export this car into another project, I just got to drag and drop that one folder. But there are still some scenes that I put inside of my scenes folder. So I'm going to make that as well. So let's go ahead and make our car. So I'm going to start off the 2D scene. Underneath here, I need to add a few things. The first one is going to be a sprite, the visual representation of our car. The next thing I want is a collision shape 2D. And with those selected, I'm going to come zoom in a bit. I'm going to open up my assets, sprites, Kenny. I'm going to go to the PNGs. We'll look at cars. Then if we double click them, we can see them. Which one do we want to start with? Is there a red one? Gotta have red. All right, so we've got our red cars down here. Do we want a sunroof? What do you want? Sure, tell you what, good enough. I'm going to select that sprite. And right where it says texture, drag and drop that in there. There we go. It now appears. So the next thing I want to do is go to collision shape. I'm going to zoom in on this car a bit. With the collision shape selected, we have to pick the shape of the collision or the collider that we want around it. I'm going to go with a capsule collider. And let's take a look. I guess technically it's not a capsule collider. It's not 3D. You get the idea, right? So the reason why I didn't pick a square is I don't want the corners because they can get stuck on things. I like the rounded edges. Sure, that means some of the car is not going to be included, at least not the visual aspect, the sprite, but that's perfectly fine. I'd rather have it bounce off stuff more than get stuck. So we'll need it about yay fat and about yay big. Maybe make it a little chunkier. And again, you can zoom in depending on the sprite you pick, get a little more precise. I'm happy with that. Let's go ahead. We'll save it into my car folder. And it's not going to be a node 2D. I'm actually going to rename this. So the node up here is what I want to rename. And you can either right click and go to rename. I tend to hit F2. I think you can also hit enter. Yes, enter as well. And I'm just going to call it car. Now we do have a warning here. And if you hover over it, it's going to tell you that the collision shape only serves to provide a collision shape. So I picked the wrong node when I started. I actually needed a rigid body 2D, or at least a type of it. And that's actually a kinematic one. So what I'm going to do is select this first node. Remember, it was of type node 2D. And if you hover over it, it tells you we can change its type just by right clicking, select change type, and kinematic body 2D is what we want. And we get rid of the warning. Now I'll save it. And I'm inside the car folder. I'm calling it the car scene. And let's create our first script. So I'm just going to hit the plus button. I'm going to switch it to a C# script. It inherits from kinematic body 2D. And the path is car slash then car, the name of the script. So let's create. This is going to open up Visual Studio for us. And we have to select a project. I'm just going to select the first one. Then I'm going to get rid of everything. Just like I always have done, even with Unity. I don't like some of the formatting. I'm just going to change a bit of it here. Perfect. So the code that we're going to write, like I said, there's a car control out there I really like. It's done by Kids Can Code. I'll post a link down below where you can actually go and get the GD script version of this. And I think again at the bottom, there's a video you might want to watch. But since we're only focused on C#, we're going to convert. So like I said, if you come down to the bottom, he's got one here where he goes through, how long is it? It's 20 minutes. If you're just going for the exactly what's going on, watch it at 2 times speed. And of course, while you're there, give him a sub. He's got a lot of really good stuff here. All right, so we're going to set up a scene. We've done almost all of this. We haven't done the camera 2D yet. I'm going to wait on that. So let's take a look at the code that we have for part 1 and see the GD script version compared to what we have in C#. So let's go line by line for now. So extends kinematic body 2D. That's just inheritance, and this is what we get here. So we're extending the kinematic body 2D. We have some variables set up. One's a wheelbase. It's equal to an int. We also have a steering angle equal to an int. Then we've set up another velocity, which is a vector 2. And in this case, he's setting it to be equal to 0, 0, 0. And then we have another variable set up to steering angle. We don't know what type it is. Now, GD script, you can get away with having typeless variables. C#, I don't want to do that. So I'm going to copy this, all its variables, and I'll give you the C# version. And now we have the C# version of, well, what we had previously in GD script. I've changed my variable types to floats because I may actually want to have these exposed in the editor, and maybe I don't want to have whole numbers. I might want to have fractionals. So because of that, I've switched them to floats. So let's move on to the next part. So we have a function here, physics process. Now this is the exact same as physics update for those coming from Unity. It fires off every physics frame. And inside of there, we're calling another function called getInput. We're going to calculate the steering. So we have 2 functions that we're calling here. And then we also have to take the velocity, and we're going to be updating it using the built-in move and slide. So when it hits something, it slides off of it as opposed to getting stuck. Well, it slides a little bit better this way. So I'm going to set this up. So the next part is, well, let's go fix up the input. Now I'm going ahead and doing the input part. And there's one thing I want to take note of for those coming from, let's say, Unity. There are 3 things we can get for as far as input goes when they're pressing down a button. We can grab the just pressed. This is the first frame it goes down. Just release, the first frame that the user lets go of that button. And then just pressed if they're holding it down. In this case, we want to go with that one. Okay, so let's take a look here at the conversion from GD script to C#. I've set up a variable. It's a type int. And every time we press a certain key, in this case, the one that we're going to be assigning to the input right, it's going to increase turn by 1. And if we hit left, it's going to decrease it by 1. Take note that every time we get this input, so every frame, we're resetting it back to 0. Then the next thing we're going to do is take that steering angle. We're going to multiply it by whatever we have here. And we're going to change the degrees to radians. Now in C#, we have to go into the math library for that, but it does work just the same. Then we want to make sure that we reset our velocity. Then we're going to check to see if they're pressing the forward key. If they are, let's move them forward. So these input keys, let's set these up next. And in order to do that, we have to jump back into Godot. So let's make sure we've saved it. Jump into Godot. I'm going to go to project settings. We're going to come into the input map. And right here, the actions, we're going to make them. So I have a right, a left, and a forward. And I have another one later on that we're going to be making called braking or backwards or something. I'm going to call mine braking. So the ones we've made are down here. All we have to do is hit this plus key and we can assign what type of input we want. In this case, I'm using a keyboard. So I'm just going to hit key and it's going to ask me the key I want. So this was for right, sounds like a D. Left, key, A. Forward, key. Now you can do modifiers as well. So Shift W, but I don't want that. I just want a W. And for braking, I'll go ahead and assign an S. Great, so WASDA. Well, I still call it WASDA. I don't care what anyone else says. So I've got those set up. Let's save it. And I'm going to hit this play scene button. So it's going to go build it. It's going to pop up a window. And if we notice when we press forward, the car moves sideways, right? So we have to fix that. What I'm going to do is come in and rotate the sprite and the collider. Anytime you have your physics rigid bodies, either in 2D and in 3D, you never really want to rotate those directly or scale them. I find it really throws off all the calculations. So I'm just going to take everything underneath it, come to the transform, and rotation degrees. I'll just do 90. And that's the front, it's got the headlights. We'll save that off, we'll come back in. Let's click, and now it should move forward when we hit the forward key. Kind of a little choppy. We'll fix that in a bit. We haven't taken into account the actual steering as well, but there is one change I want to make inside of our code, and that is the way we're getting the input for turning left and right. I want to condense this a bit. I like doing it a different way, but this is the way he has it written, so if you want to stick to that way, that's fine. This is the way I like to do it. All right, so I've changed my turn into a float. And now instead of just getting is the action pressed, I'm getting its action strength. Now I'm taking the right, which was positive. Think of it as if we have the graph set up on the x-axis, pluses to the left, or sorry, to the right. That's why we have the right. Then we're going to subtract whatever we have for the left. And this will tell me what angle I need to turn at. And then I'm going to do some multiplication down here. Now because of that, we got a float instead of an int. We might have to increase the actual angle that we turn at. And I like to have those exposed inside of my inspector. So we'll jump back in. I like to have those shown up here when I have my car selected. Now in GDScript, we have the export tag. We also have that in the C# version. And there we go. Now if we save it, come back in, we need to build it. And there we go. We now have it exposed here and we can change it. And just like in Unity, whatever you have typed out here overrides whatever you have it starting at here. So take a moment here, start thinking about the car you're going to build. What elements, or at least what variables, do you need to have exposed out here? I'm going to jump back into the code and we'll open up the website again. And the next part is the calculating of the steering. So GDScript version. And some of these variables get capitalized, like position, as we see here, and transform. If you're coming back from Unity, this is essentially like your transform dot position. This is the position of our actual, whatever this script is attached to. In this case, it's our kinematic 2D body, or kinematic body 2D. There we go. And again, the transform that I'm attached to, wheelbase, prefixed all of my global privates with the underscore, so we know exactly where this variable was made. We're going to do it for the front wheel and the back wheel. We make some adjustments, and we're going to take the front wheel, make sure that it's rotated to the angle that we wanted. Calculate our new heading, normalize, so it only has a length of 1. Readjust our velocity, and then rotation, take note, capital R, so that means it's, again, coming from Unity, transform dot rotation. So it's the rotation of this object. And in Godot, we refer to these as nodes. Coming from Unity, you'll probably hear them called game objects. I tend to use them interchangeably depending who I'm talking to or what I've just been doing lately. So if you hear game object or you hear node, you know what I'm talking about. So let's save this off. We'll jump back into Unity and let's try it out. We should be able to turn now. So we can go forward and now we can turn. If you want to be able to turn faster, we can come up here, change the angle. So I believe greater makes this turn faster. Oh, there we go. So season to the taste you like. I'm going to keep mine at the default of 15 for now. Again, we can change that later. When we get to horsepower or something like that, we can go ahead and, or engine power, we can put that up here as an external or an exported variable as well. So let's jump back into our code and look at the next part. So part 2, acceleration. So here we're going to be setting up the engine power variable. It's a global. And again, even though he has it written down as an int, I like to put it down as a float. So let's scroll up to the top and let's add engine power and acceleration. So I'm going to put engine power. I'm going to move a few of these around. I'm going to take this first one. I'm going to move it up here. I like my exports to be at the top, and I don't necessarily need a space here. I like the export on the same line as well. So again, export private float, and it's an engine power, and we're starting off at 800. And we need an acceleration, which I'm going to put down here at the bottom. Now I'm going to save this off, and I want to see this exposed right away. So I'll jump back into Godot and just hit this build tool. Now, if you're doing GD script, you don't have to hit the build in order to get to show up here. It does it automatically. This is just something you have to do if you want to use C# instead of GD script. But it's exposed. It's showing up. Great. Let's move on to the next step. So we're going to be changing our get input. So let's scroll down, and we'll be modifying a lot of stuff over and over again. But all this code will be available on GitHub, and I'll leave a link for that down below as well. So if we take a look here, we're going to change the input code to apply acceleration instead of directly changing the car's velocity. So if you read through, right here's the change. So we can come in, and we're going to use our engine power instead. We'll come back into here, and we also have to change the physics process. Now, I tend to have all of the built-in functions or events at the top. So I'll have my ready, my process, my physics process, anything that Godot gives us, pretty much anything that's going to have that override in it because of Godot. And I keep them up at the top. It really doesn't matter. It's just the way I organize it. I like it up at the top. Then anything that's particular to this script that isn't given to me from Godot, I put down at the bottom underneath it. Organize it the way you want. Doesn't really matter. Doesn't affect the outcome. But let's take a look here. We're moving the acceleration is equal to vector 2.0. I believe we moved that out of here, don't we? Or no, sorry, that was in the get input, and it's actually right here. There's no reason this is tabbed in. Not sure what happened there, but we don't need it anymore. So let's get rid of it. And I'm not spotting any other changes. So let's jump back into the physics process. And again, GD script, time for the C# version. And there we go. So we have to add the acceleration is equal to vector 2.0. We're still calling get input. We're still doing calculate steering, passing in the delta. We're going to take the velocity and we're going to add to it the acceleration times the delta. And then, of course, the velocity, we're going to reassign back into it. Whatever is returned from move and slide, passing in the velocity itself. So we'll save that off. And if everything works good, the only thing left is adding friction and drag. So there we go. Our car can accelerate. And we can't really see the sliding and skidding until we actually sit down and put it like a racetrack or something for it to go over. And we haven't added braking yet either, have we? I forgot to take a look to see if we have. I don't think we have. We have not. So let's jump back into the code and take a look. So we have two more variables to add, the friction and the drag for our car. So I'm going to come up and I'm going to add them right under line 13. And they are both floats. Now do take note that both of these values are negative. So now we're going to create a new function called apply friction. And we're going to call that every physics frame to make sure it's updated. So I'll come down to the bottom and I'll make that function first. So apply friction. And here we go. Presto changeo. Let's go ahead and take a look at the C# version. So we'll take the velocity, which is a vector 2. We're checking to see if the length is less than 5. If it is, we're going to reset it to 0. Then we're going to set up the friction force and the drag force. And then we can adjust the acceleration based on the drag force and the friction. So we're going to come back up to physics processing. Let's implement it. And we do that simply by, well, just calling the function. So we'll save it, jump back into Godot and try it out. So now when we start, we let go, we can see that we slow down, right? Let's jump back in and we're getting close to the end, gang. So part 4, which I believe is the last part. Oh, no, there's a part 5. So here's where we add the reversing and the braking. But at this stage, you should be able to take a look at it and get at least a good idea of what the C# version is, especially at least what I'm assuming is you already know some C# or Java, something similar to C#, any C style language. So let's go ahead and implement this. So max speed reverse and braking, those are globals. We'll put them up here. I do want max speed reversing as an export. So I'm going to put that one first, but braking, I don't. Now we can go much further with this after we're done with the game by looking at something like resources. Again, for those coming from Unity, resources are, I guess, akin to scriptable objects. So we could set up a bunch of, let's say, tires or braking or engines or whatever you want and have different versions of them or different resource versions of them. And we could just drag and drop these different ones in and they could contain all of these parameters for us. So as you race, you win money, you buy, better tires, better engine, paint jobs, whatever you want. That's not really the point of this little mini series. The whole goal is to just get more C# stuff out there for Godot. So we've got something that works. It's really good inside a GD script. I just want to give you the C# version of it. And then of course, we'll add some more stuff onto it. So with that said, max speed reverse. I'm going to keep the variable the same. And he has that at 250. Then the last one I have will be down here. And that is braking. Great, braking done. Let's move to the next part. So we have to go back into get input. We're going to come down to that right here. And we have to take into account if they're hitting the braking key, we want to slow down faster than what drag's doing for us. So we just have to add this one if block right under here. So let's do it. Now it looks like somewhere along the lines I missed a step. We have to change the vector, or sorry, the velocity itself to the acceleration. So let's do that now as well. And let's make sure we're using the right brake. Let's try it out. So we drive, accelerate a little bit slower at the start, which is fine. That's what we wanted. Now, we hit brake. It doesn't seem to be braking any faster. Let's take a look here. I should print out my speed. I'm doing something wrong here. And I already see what I did wrong. I've got braking at 450. It's a negative 450. Let's try it one more time. And there we go. Braking works a lot better now. Now you may wish to, again, expose certain variables out here that I don't have. By all means, go ahead. You know how now. Okay, so we have to come back down and to calculate steering. And we're going to change a few things here. So we'll slide down. Here we go. And there's actually not that many changes left. We come down, we have a few more variables that we're going to expose. And then the final version of calculate steering. And then we are done. So let's go ahead. Let's implement all the changes now. And we'll just jump straight to the end. All right, so we've made our changes. There are a few things I'd like to change again, but for this video, I just want to completely convert stuff over to C#. And we'll jump into Godot and take a look at our final version. So we'll just go ahead, hit play, well, for this scene, and let's try it out. So now we can see it swerve a bit as we start to skid. So in the next video, we'll learn auto tiling and we'll make our first racetrack. So don't forget about all that YouTube jabs where you hit the subscribe button, make sure you turn on all your alerts and yada, 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 tell all your friends. And don't forget to tell your mom as well, eh? Bye-bye.